In this video we're going to be discussing inverse trigonometric ratios. I've written a few things here, so if you'd like to pause and write those down you can. We'll be explaining them as we go. But I have one very important thing written right up here in the top. Inverses are not reciprocals. That's something that can be a little confusing because in math class you might have been told that if you have, let's do it down here, a and you multiply it by 1 over a, that's 1. So these are kind of undoing each other. While it is true that if you multiply this a by 1 over a, you do get 1, and you're multiplying by a reciprocal, when we talk about inverses, we really want to start to think about operations that undo each other, like addition, subtraction, multiplication, division, squaring and square rooting. And with trigonometric functions, we need to be very careful with what a reciprocal is and what an inverse is, and the two are very, very different. So let's take a look at these triangles that I've written down. You've got this angle here at 33 degrees, and that's the actual angle measure, and you can measure it as well if you'd like to on your note sheet if you're following along. And then I've also measured these sides here. So this side's 3.6, 5.5 in centimeters, and then you've got the larger triangle here with 5 and 7.5. So the question is, could we logically conclude something about this angle theta? Let's take a look at our ratio here. We're going to do the opposite over adjacent. For some of you, you kind of know where I'm going with this already. Try to think ahead a little bit, think which trig function that is. But anyway, we'll do 3.6 and divide it by 5.5. And you can see we get around 0.65454, and it looks like it keeps going on for a long time there, repeats. Let's take a look at this triangle on the right hand side. We're going to do 5 divided by 7.5. And this is almost exactly the same number. In the perfect world, these two triangles here would be, the ratio of the opposite over adjacent would be exactly the same. And if you look at these two triangles, they kind of look similar, and we also know that they are indeed similar triangles by the SAS property from geometry, that if you have two sides that have the same corresponding sides, the corresponding sides, the ratio is the same of those two. In other words, if you take 3.6 divided by 5.5, 5 and 7.5, if you get the same value there, as long as there's an angle in the middle that's congruent, of course right angles are congruent to themselves, then we are allowed to prove that these two triangles are congruent, and this angle here must be the same then as this angle. We know that in similar triangles, all three corresponding angles are the same. So this is something logical that we could do. We could conclude that that is also 33 degrees. Notice how if this side, if those ratios were different, in other words, if this was maybe, 5.5 or something like that, then this side would be longer. And let me pull this down a little bit. And the angle would have to change if this side were longer. You can see here if we increase the side length, that the angle would get bigger. Matter of fact, if you had 5.5 here or 5.5 here, that angle would have to be 45 degrees, or bigger than 33. Likewise, if this side is smaller, throwing the ratio out of proportion with this one, that the angle would also be different. So this is kind of a neat thing to be able to do, and that is to say that if we have two similar triangles like we do here, and if we just know the ratio of the opposite and the adjacent side in this case, we can also conclude something very specific about the angle. It also has to be a very specific thing. And as a matter of fact, if you typed in the inverse tangent, which is second tan button, and you can see the little -1 here, that does not mean reciprocal, so a little bit confusing. It means inverse. And you typed in, let's go with this 0.6 repeating here, so we'll go with 2/3. We'll see what it comes out as, and you can see that this angle here is indeed 33 and a little bit, maybe closer to 34, but it's very, very close. Of course, with our measurement here, precision of our instruments, it's going to be off maybe a little bit, but it should be pretty darn close. And that's kind of nice. As a matter of fact, if we did know what the tangent was, in this case the tangent is 2/3, prior to having these wonderful graphing calculators, we had to look all these up on a table. We're going to fill in some blanks here at the bottom. This is very, very important that you get this. I'll do this in a different color for you. The cosine, which is not an inverse, it's a regular cosine. We always take the cosine of an angle, and this could be measured in degrees or in radians, some angle, the size of an angle, and that gives us the ratio that we want. Of course, this is cosine, so this would be very specifically the adjacent over hypotenuse ratio. When we write this symbol here, we do not mean reciprocal, we mean inverse, so the proper way to say this is the inverse cosine of the ratio can tell us the angle measure. So you see how these are kind of flipped here, but I use the word flip loosely because some of you out there are thinking, oh, reciprocal means flip. No. For here we're looking at the inverse, so these positions are flipped, but they mean something very, very different. For instance, the reciprocal function of cosine is secant, and that's nowhere in here. Okay, so it's very, very important we take the cosine of an angle, that gives us a ratio, whereas if we take the inverse cosine of a ratio, that gives us an angle. There is another way to write this, and the inverse here is going to be written in a couple different ways. So let me give you one popular way to write it, and it's the same one here. So you could take the inverse sine of the ratio, y over r, or opposite over hypotenuse, and that will give you the angle. Or sometimes this is written arc sine of y over r, still producing the angle. So this arc sine just means inverse, same thing as this one. The reason why people would use an arc sine and not this little -1 is because if you have like x to the -1, that's 1 over x, but we don't mean that. So it can be a little confusing using this symbol, but we will stick with this mostly. We'll do some arc sine stuff too. It really means the same thing, of course, but we'll stick with this just because your good old calculator has that on it. So we'll try to keep with the naming convention.